Oh, sorry about that. My last video got cut off before we were able to finish. So let's just continue with dilutions right where we left off. So I just gave you the dilution equation, and let me review it real quick because we're about to use it. So we have the molarity, MC, molarity of the concentrated solution, and we're going to multiply this by the volume of the concentrated solution, and that's going to equal to the molarity of the dilute solution times the molarity of the, or sorry, volume of the dilute solution. Okay, so that's our dilution equation. So in your study guide, which I have out, right under that dilution formula, there's a couple of dilution problems to look at. So it says, for example, if you purchase a 12 molar hydrochloric acid, HCl, and you want to dilute it to make a 1 liter, okay, a 1 liter of a 2 molar HCl, you need to calculate your dilution as follows, okay? So essentially, follow along as I go through that math. So remember, I'm going to write this down, the molarity of the concentrate that's been given to us, and I would recommend you do this as well, okay, is 12 molar, okay, HCl. That's our molarity of the concentrate. The volume of the concentrate, we don't know. That's our unknown, and that's what we're actually going to solve for. That's our X value. And then the molarity of the dilute, that's our new desired molarity, okay? This is what we're starting with. It's our concentrated molarity, and this is what we want to eventually get to, our dilution. So that's going to be a 2.0 molar hydrochloric acid. And then the molarity, or sorry, the volume of the dilute, our desired volume, is going to be a 1 liter solution. Okay, so we want it to 1 liter. So essentially, the math looks like this. I'm going to use this dilution equation and plug these variables into that equation to solve for the VC, essentially. Okay, so let's do that. So the molarity of concentrate, 12 molar, times the VC, which we don't know, is equal to MD 2.0 molar times the volume of 1.0 liters, okay? So there's the setup. And so then I just multiply and divide by the 12, and that will give me the volume of the concentrate, which happens to be, as I calculated, 0.167 liters. But I'm going to go ahead and convert that into milliliters because that's really what I'm going to be measuring out is in milliliters. And so that is 166 milliliters. But to the right significant digits, really, it should be 170 milliliters. Okay? So I need to take essentially 170 milliliters of my concentrate to make my dilution. Okay, so how do I go about doing that? Okay, so when we draw a diagram up here, I'm going to erase this right here and draw a diagram of how you're going to do this. Okay, so remember I showed you our solution that we made of sodium hydroxide. Well, let's pretend that this solution is really our 12 molar hydrochloric, 12 molar hydrochloric acid solution. Okay. So what I'm going to do is, here's my 12 molar HCl solution, okay? What I'm going to do is I'm going to pipette out of this 170 milliliters, okay? So the calculated volume, that's my BC volume, okay? I'm going to remove by pipetting 170 milliliters out of that. And then what I'm going to do is I'm going to transfer that over to another flask, okay? And this has got to be a 1 liter flask, right? Because we want our final diluted volume to 1 liter. Okay, so I'm going to basically dump that in there into that 1 liter volumetric flask. Okay, so again, these are both volumetric flasks. Now, once I have that in there, so I'm going to have like what? This is going to be 170 milliliters of HCl. Okay, and that's going to be again from the concentrate. And then all I'm going to do is add water now. So add water up to the, say this is going up, and here's my mark here, okay? All up to the 1 liter mark. So I'm just going to add water all the way to the 1 liter mark. And once I've done that, I have my dilution. I'm done. I'm finished. I have my final 2.0 molar solution of HCl. And that's all you need to do in order to dilute. Figure out what is the concentrated volume you need to remove from the concentrate, pipette it out, make a pipetter, or a graduated cylinder, something like that. But you got to remove 170 milliliters or the volume that's concentrated from your concentrated solution. Put that into another volumetric flask, just pour it in there, right? And then the rest of the volume is added by water. So you just add water all up to that mark and you're done and you have your dilution, okay? It's pretty easy, okay, as far as making dilutions go, right? So now, there's a few calculations in your study guide that we can run through. Why we're doing this, right? Again, these are some calculations in your study guide. It says, number one, it says lye, sodium hydroxide, is an effective drain cleaner. Show how to prepare 100 milliliters of a 0.100 molar sodium hydroxide solution, okay? So just like I showed you before, we got to first, if we're going to make a solution, we got to take and determine how much mass we need to weigh out. So I know that I have 0.100 molar sodium hydroxide molarity solution that I need to make. And the volume of that is 100 milliliters or 0.100 liters. And that gives me 0.0100 moles of sodium hydroxide, okay? And then I can take my moles, 0.0100 moles of sodium hydroxide, and just solve using dimensional analysis the mass. So I know that 40.00 grams to 1 mole of sodium hydroxide. And that will give me a mass of 0.400 grams of sodium hydroxide, okay? So that's the mass that I'm gonna put in my, in this case, 100 milliliter volumetric flask. Just put it in there with a funnel and then fill it halfway with water, stir it to get it dissolved, and then fill the rest up with water to that 100 milliliter mark, okay, as I showed you earlier. And that's it. That's all there is to it. Okay, so let's look at some other problems here. Problem number 2 says that you have a sodium thiosulfate and you need to make a solution of sodium thiosulfate. All right, so it says that we have a 250 milliliter solution of a 0.120 molar solution of hypo, which is sodium thiosulfate. So again, the mass. So I'm starting out with 0.120 molar of Na2S2O3. Actually, parentheses, multiply that by 0.250 liters, and that will give me 0.0300 moles of sodium thiosulfate. sulfate, okay? And then I convert my moles of the sodium thiosulfate into grams. So the molar mass I calculated is 158.12 grams to 1 mole, and that gives me 4.74 grams of sodium thiosulfate. Okay, again, all I do is pour that into, in this case, a 250 milliliter volumetric flask. Water halfway, stir it, get it dissolved. Then once it's all dissolved, water all the way to the 250 milliliter mark, and you've got your solution. It's all done. Okay, that's again all you have to do. That's the process. Okay. All right. Let's see. We got another one here. Okay, number 3. You just got to calculate the molarity. You know how to do that. I'm going to let you do that on your own. But essentially, the final answer for number 3 should be 0.480 molar. So just make sure that you can calculate that. It's a simple molarity problem. Okay. There you go. All right. Now let's go to 4. 4 is our first dilution. Okay. So it says car batteries have 6 molar sulfuric acid that you use, basically. You're going to purchase a 12 molar sulfuric acid, and you want to dilute that 12 molar down to a 6 molar, okay? So in this case, you have your molarity that's concentrated is 18.0 molar, H2SO4, okay? The volume of the concentrate, again, we don't know. That's what we're going to solve for, right? The molarity of the dilute, that's our desired molarity. We want a 60 molar H2SO4, okay? Sulfuric acid. And the volume that we need, or the volume of the dilute that we need is 2.0 liters, okay? So all I'm going to do is set up my problem with using the dilution equation. Remember, M concentrated, B concentrated is equal to M dilute times B dilute, okay? Plug it in. So I'm going to 18.0 molar times BC is equal to the 6.0 molar times the 2.0 liters. So VC is equal to 0.667 liters, or 667 milliliters, okay? So essentially, this is the volume of the concentrate. So again, here's my 12 molar, and I'm going to remove 667 milliliters out of there, pipette it out, put it into, in this case, into a 2-liter flask. Pour it in there, right? And that puts 667 milliliters in there. And then add water all the way up to the mark. And then you got your final solution of 6 molar that you're trying to do. Okay? So I know I'm going through it pretty fast, but go back and review the video if you need to. Okay? All right, we got one more to look at. Looks like it's another dilution. So we got methanol, and we want to basically take a concentrated methanol of 24.7 molar, and we want to dilute it down to a molarity of 10.0 molar, okay? The volume of the dilute is 8 liters. So the volume of the concentrate is what we don't know, right? Still, is what we still need to calculate. So again, I plug it into my equation. I'm going to take 24.7 molar, okay? Multiply it by BC, equal to 8 or 10.0 molar times 8.0 liters, and the VC concentration is 3.24 liters. Okay, so that's the volume of the concentrate that I need to pull out, pipette out, put it into another container, possibly an 8-liter container, which is huge, and then dilute it down to the mark. Okay, and that's all there is to it, right? So that's it for lesson for this lesson essentially now. So basically go back and review your notes, review the videos, and come to class prepared to answer questions and to make solutions. And so that's it for now. Bye-bye.